So, on to the third part of my presentation, and this is something I'm really excited to talk about, is how can we integrate touch into AI systems and human AI interaction? In the last two parts, I talked about Kissinger, the remote kissing device I developed to integrate affective touch into digital communication with each other. We also talked about how touch is the most powerful sense that conveys emotions, builds trust, and forms connections with humans and machines. So this motivates us to push the boundaries of how AI and robotic systems are going to interact with humans. It's not just about making machines smarter, but also making them more emotional. So recently we see that big tech companies like Nvidia, Meta, and Tesla are all investing heavily into AI-specific hardware. And this shows that we're transitioning from software-only AI to AI systems that are physically embodied, like robots, devices, agents are present in our physical environments. If AI is to become more physically present and more involved in our physical environments, we don't expect them to only interact with us through text, voice, and images. We also want them to be able to perceive, understand, and respond to touch interactions, just like how we interact with each other in our physical environment. I developed a framework of what I call the Haptic-AI Framework, and this provides a clear and standardized roadmap for how we can bring touch into AI systems. I put this framework together after consolidating all the research across multiple disciplines like affective haptics, affective computing, haptic technology, machine learning, human computer interaction, human robot and human AI interaction, and even including neuroscience and psychology. This framework allows us to understand what are the research areas we need to focus on, identify the current technologies we have, and the challenges we still need to solve. This framework consists of 4 layers, which work together to allow AI systems to perceive, understand, and respond to touch. The first layer here is the perception layer. This is the system's sensory layer, where it captures and processes the touch inputs, identify the features of the touch inputs like the pressure, speed, and even texture. And it also integrates data from other senses like voice, vision, text, and create a more richer understanding of the input. To build this layer, we need touch sensing technologies and we need the haptic devices. And with robots, we need the robotic interfaces that can sense the touch input from the users. We can also use the haptic interfaces to collect touch emotion data sets, which can be used to train machine learning and deep learning models to recognize the emotions from touch gestures. The second layer is the cognition layer, which is the brain of a touch-enabled AI system. This layer helps the system to understand the context of touch and recognizes the emotion and intent of the user's touch input. Here we've got a research area called touch emotion recognition, which is building classification methods using machine learning and deep learning models and multimodal fusion models to understand and classify the emotions behind different touch gestures. And these models also need to be trained to understand the social context behind each touch input. Research on emotion appraisal models and neuroscience of touch is very useful here to build robust classification models that can understand the emotions of touch gestures. So once the AI knows the emotions and meanings of touch, it needs to be able to decide how to respond to these touch inputs. So this is where the touch decision model comes in. Based on how the system is built, it can choose to respond in the form of text, voice, images, or even touch if it has some kind of touch actuation technology. Finally, the integration layer brings together all the components to build haptic AI systems into real-world applications. We see a lot of application areas where touch can be very useful to create more emotional and more natural human AI interactions. Let's walk through a typical haptic AI interaction. The user will interact with the system through touch interaction, and the touch sensors will pick up all the details like force, frequency, and speed of your touch. This, the touch sensors will pick up the details of your touch inputs like the force, frequency, and speed of your touch. And it can also combine with your facial expressions. And if you're talking to the AI systems, it can analyze the tone of your voice and the content of your conversation. And the system will analyze what is the intent behind your touch inputs and what are your emotions at the moment. Are you seeking comfort? Are you showing affection? Or are you signaling something? Based on that understanding, the response layer is going to decide how the AI system is going to react. Is it by touch, text, or a voice reply? Through this process, the AI system will create a full emotional feedback loop where it can sense your touch, understands your feelings, and respond in a way that is natural and emotionally intelligent. Finally, let's talk about all the possibilities where haptic AI can really transform so many application areas. First, we got this really hot topic now called emotional AI. So, compared to traditional AI, which are very good at performing tasks and helping us with our productivity, emotional AI are AI systems that are built to understand and respond to emotions. And these can be AI agents that show emotional intelligence. It can understand your emotions through multimodal data, for example, from your facial expressions, your tone of voice, content of your speech, and the way you touch. In the social robotics area, we have companion robots, robots for children, like this Moxie robot here, robotic pets, and even carer robots for the elderly. We also see potential applications of touch AI in the healthcare and therapy area. We can have AI therapists and therapy robots that don't just talk to you through text and voice, but can detect the stress and emotional issues through touch and provide the mental support and comfort with affective touch. And lastly, in VR and AR, we can add touch interactions to virtual worlds to make them feel more real and immersive. And it can also really enhance the physical and emotional user experience of these applications.